Here we see a copy of our notes for today. I'm actually going to zoom this in if I can. I'll do it during the activity. So we are going to talk about averages today. A lot of us have heard of an average. Last class we talked about histograms. They both describe data, trying to get a great picture of what our data looks like. Let's discuss in our groups why we might prefer a histogram over a average by placing, there's four boxes of information, placing each of those boxes into the 4 boxes below. So, for example, for histogram advantage, it'll come from one of those 4 statements at top. So let's go ahead and form groups of 2 and discuss what to do out loud.
So the average only provides the disadvantage, right? Yeah. So it's definitely a disadvantage.
The average only provides the center.
Meanwhile, our histogram,
let's just let Mark
that's precise information right there.
Yeah. And then
The center, so the general information would be the disadvantage.
yeah.
Exactly.
I think precise information is probably the histogram.
Yeah.
And then visually.
Wait, that's right.
That actually might be the other one.
I think it's the
But
other
a
way.
visual histogram or an average wouldn't provide precise
Precise
information.
information.
Yeah.
Okay.
Like
Oh.
this one and this, like the center of the data would be.
Only.
Okay. Okay.
But
You're probably right.
I know.
what provides the center of data?
What provides the center of data? What do you think of when you think of the center? Let's say
Average.
Exactly.
Was that an advantage? That's in the disadvantage that only provides general information.
Well, the average is a calculation, so it's actually pretty specific. It tells you a very specific number.
Yeah,
Yeah.
So I wouldn't consider that general.
you're right. All right.
Okay, I think it's time to go over these. So the histogram, the advantage of the histogram is it provides a visual because it's a picture. Here's an example of a histogram. I gave you one down here. Probably this is a visual. So I'm just going to draw arrows to make it easy. The visual goes in this box here, but I want you guys to actually write it out, the statement. I'm writing arrows to save time. Okay, what's a disadvantage? Now someone said only. Yeah, only is a disadvantage if you have the word only in front of the statement because it can only do that as opposed to doing multiple things. So the disadvantage of the histogram is it only provides general information, meaning this is very general. We see a picture, we don't really know anything specific about the data set. We just see a beautiful picture, and while it's a nice picture, we really don't know like the number of people that fall between a 3.2 GPA and a 3.3 GPA. So only provides general information is the disadvantage of a histogram. So again, arrow to that box. Okay, what was the advantage of an average? We have 2 left. What's the advantage of an average? Is it only provides the center or is it provides precise information? Good. You're going to calculate an average. It's going to spit out a number. That's very precise. It's not general, it's very precise, and you get that exact number that gets spit out. So, therefore, we put that one over here. Okay. And the disadvantage is as far as an average goes, the average is going to be in the middle. It's not going to be on the side, and so you know nothing else about the data set. You only know the center of the data set for an average. So the last one, by also process of elimination, is this one over here. Any questions on number 1? Somebody told me I should say, instead of any questions, what are your questions? Because that encourages people to ask a question. Okay, I want everyone in number 2 to put down where they think the average is. So basically, if you think the average is over here, put like a little line over here and then eyeball the number. That looks like 3.99. Is the average going to be over there? No. So go ahead and put down where you think the average is. And again, you can discuss this in the groups that you're in.
I think it'd be like these, like with all of these, like throw the average up a little bit. So these are the most common. Yeah.
I like that.
I don't know. That's what you're doing.
That's actually one possible answer. For this one, there's actually unlimited answers. As long as you put a value that's in the middle, that's fine. That's an average. Because average is just a point in the middle. It's a precise point in the middle. Usually there's a formula. You should follow a formula to get your average, because otherwise people are going to be like, why did you pick 3.35? Yes?
If you come to the number of people, wouldn't it be exactly 3.4?
So 3.4 may be either the mean, median, or mode, which are the, oh, I don't want to give away the answer. But what were you saying?
Because I do that, I do the math side of it, and I counted the amount of people, like it starts with 1, and it goes 2, 3, 4, 5, 6, 7, 8, 6. And
Did you add all these numbers and then divide by the total?
No, I was doing number 2.
You're doing number 2. You added the 3.1, 3.2, 3.3, 3.4, all these numbers together and divided by the total?
Yeah.
So that would not be the mean, median, or mode, but it would be a unique average that you calculated based on what you decided to choose. So you created a new formula, which is okay, totally okay. Mathematicians do that all the time to find new, different kinds of calculations. But it wouldn't be one of the standardized averages that we're going to learn about in this class. But it did give you a point that's in the middle, which is 3.4, so there's nothing wrong with that. Okay, so based off of number 1 and number 2, go ahead and circle which of these are averages. I decided we're not going to use pull everywhere for this one. So just go ahead and circle. Because pull everywhere only lets you do 2 answers. It doesn't let you do 3. Not that 3 is the answer. Well, it might be the answer. So it turns out that as far as the mean, median, and mode go, they're all in the middle. So they would all be averages. So make sure that you circle all of that. Now, what have we been told in our previous math classes? Did our math teachers usually tell us that the mode was an average, or that the median was an average? No, because they usually just go by the mean. They've just had that ingrained in their head that the mean is the only average and that's the only average you should use. Well, in reality, sometimes the mean is not the best average to use, which in that case, you want to use the median or the mode. But most of the time, what do you think is used? The mean. So usually when we think of average, we think of the mean, just because most of the time that's what people use. We're going to learn why some of the other ones are a little bit better. So here we have now the histogram again, and this time I told us the number of students that scored GPA between 3.1 and 3.2. Now you'll notice there were 42 students, and if you add 6, 8, and 7 together, that's 21. And if you add 6, 5, 4, 3, 2, and 1 together, what number do you get? Also 21. So there's 21 over here, and there's 21 over here. In groups of 2, what do we remember about that point where there's half on this side and half on that side? And then let's use that information to critique this statement here. So this, we're saying a student who earned a 3.4 GPA had an average GPA. So maybe we can get a little bit more specific than that. Okay, groups of 2.
How is it?
Yeah, it was like middle of the pack. It doesn't mean that was the average of the group.
So that
So
would
if you had a group where you were like just smack down in the middle, that didn't, the average of the group. I said like, all these statistics is actually I said 3.4.
But like you said, it is a guess.
It's like the middle of the pack, and it doesn't always mean like every number in the middle of the pack is going to be the average for the group.
Okay, what did our high school teachers tell us? The point in the middle is called the median. So really this 3.4 here is the median. So it had we can be a little bit more specific and say a median GPA. Now, as I point out in one group, this is a guesstimate because we don't know the exact number of people in these cases. We just know that 7 people had a GPA between 3.3 and 3.4, 6 between 3.4 and 3.5. So that actually makes our median a guesstimate. But we were told that the median is that point in the middle. So that would be the best average in this case would be the median. Now, again, the reason why it's the median is because if you add these 3 together, you get 21. And if you add all of these together, you also get 21. Any questions on that? Also, sometimes it's good if you do have a question, sometimes it might get answered later on in the lecture. But I often recommend if you don't want to ask your question now, to write that question down and then to revisit that question at the end of the lecture. And of course, I'm not going to be rushing out of the room, so you can still ask it if I'm still here. Okay, so we have to be a little bit more specific though. The median is the value exactly in the middle of the data set when, okay, fill in the blank. Because there's one more thing that I want. So, groups of 2 and 3. Okay, here's a big hint. Here's a big hint. Oh, there's 1, 2, 3, 4, 5 values. Does 19.8 look like a median? Does that look like it's really in the middle? I mean, okay, it's in the middle, but there's some big values here and there's some more median values.
Should we also say also Yeah.
And also,
Okay. Is 19.8 the median? No. What do you have to do with the values to find the median? good. Put them in order. So what I like to say is the median is the value in the middle when values are arranged from least to greatest. Is that the only answer? No. What about greatest to least? Is the median still in the middle if you say greatest to least? Yeah, so make sure to put a definition that works really well with you, because that's what's important. Summarizing things in your own.
Greatest to least?
It can be greatest to least. You could say if the values are arranged from greatest to least, the median is still going to be in the middle.
Yeah, that's what
The only difference is that the bigger values are on the opposite side and the smaller values are on the opposite side. And again, if anyone has a question, just feel free to stop me and ask. Okay, let's go ahead and find the median for this example here. So 6, 7, and 8, they all use this example here. So let's go ahead and find the median for, actually let's do it for both 6 and 7. And since we can just go ahead and type our answer into Poll Everywhere since we haven't used it yet. So go ahead and calculate it. I'll come around if you need some help.
Just because it's like the difference between them. So the difference between them or the.
Don't we have to arrange the values?
Wait. Isn't just great?
And then the next one, take off.
Not exactly, because when you rearrange these, you're just moving.
Yes, that's like also.
The median could be So we're just actually doing number 6 because if you can't do 2 Poll Everywheres at once, unfortunately. Let's see our results. Okay, those are all very, very different. Okay. Okay, here's the answer. What do we have to do with the values? Arrange them from? So 19.8 is the first one, 22.4, then 27.5, then 31.8, and then 37.9. And the median is which one? The middle. So there's our median. The answer was 27.5. Okay, for number 7, we're removing the Walmart one. So remove the Walmart one and then do it again. Make sure to write out the numbers. Yeah, but I have to clear the results. Okay, now do it. Okay, let's see our results. You know, I don't think it's doing, I think what it means is 24.95 is the most common answer. But I wish it would actually put the little point between the 24 and the 95. That's kind of confusing. Okay, so the reason why it's 24.95, so we're going to delete the last one, so it's 19.8, 22.4, 27.5, and 31.8. And the median is now in the middle. How do we find the middle number between two numbers here? Good. You have to add the 27.4 and the 27.5 and divide it by 2 to find the point in the middle. So when we do that, I'm just going to do it down here. 22.4 plus 27.5 divided by 2, that's 24.95. And that's our median. So our original median was 27.5. We removed that huge, really huge number, and it went down to 24.95. Number 8 is a word bank problem again, but we have this full sentence, and only 3 of the words are going to be used. So go ahead and put 3 of those words from the boxes into 3 of these blanks right here. And this is not a poll everywhere question. And again, we can discuss this with our partners.
Yeah, it's not much. Plus did change much since then. It probably did not change much.
I know, that's what I was wondering.
Because 1 or 2
From like 27 to 100. Yeah.
Oh, no, because an extreme value. Extreme value cannot typically be based immediately based off 1 or 2 values. What? Because 337 was so much higher than this. So it's that extreme. That extreme value is really
Yeah.
Okay, let's go ahead and share our answers. The median blank changed much. Did the median change that much?
No.
No, so it did not. The median did not change much when the outlier was removed. What's an outlier? An extreme value, meaning it's very far away from the other values. Was Walmart's donation like really a lot bigger than the other ones? Yeah, it was like really huge. Okay, this characteristic is good because blank values cannot have too much influence on the median. The best answer would be an extreme value, because in this case we were dealing with an outlier, which is an extreme value, and that extreme value cannot have too much influence on the median, which is good. You don't want an outlier, for the most part, to have a huge influence on the rest of the data if there's only one value. That would be like if the average test score was a 70, but that was only because somebody got like 150% on the test and everyone else was failing. Would that be a very accurate average? No, because the outlier pulled it away, and outliers should not have that much influence on the median or the average. Okay. However, the median is only based off of how many values in the data set? 1 or 2. In which problem was it only based off of one value? Good. When we had an odd number, the median was in the middle. That's one value. And when we had an even number, we based the median off of the two values in the middle. So the median's only based off of one or two values. But that's kind of a disadvantage as well because it's only based off of one or two values. So in contrast to the mean is calculated using blank the values in the data set by adding them together and dividing by the. Go ahead and form your groups and fill in the blanks. Looks like most of us have already done it, so. No, just that was for number 8. Okay, so the mean in some ways is better because it's not based off of one or two values. It's calculated using how many values? All. The mean is calculated using all of the values and then dividing them by the total number of values. Okay, next, let's do 10 and 11. So we want to find the mean. So to find the mean, you add the values in all the values in the data set and divide by the total. So let's do number 10 and 11, and start with number 10 and then do it in poll everywhere. So I'm going to clear the results here. So when you're done adding all the values and dividing by the total, you'll put it into poll everywhere. Okay, let's go ahead and show the results. Yeah, that's correct, but again, it didn't do what I wanted. It's really 311.33. Again, it's weird like that. You guys are typing in you're typing in 311.33, right? Yeah, I'm gonna have to restructure some of these problems. Okay, so we just add them all together. So 149 plus 906 plus 183. We've done this a lot of times. 107. I recommend doing this on a calculator that will do this all in one step for you. So those kind of calculators are either graphing calculators or calculators like this. I love this calculator. I saw one person with it. Great choice. 311.33. Okay, go ahead and do number 11 by removing Walmart again. Remove Walmart and see what happens. And, okay, we can do the poll everywhere thing. Okay, I think that's the correct answer, 192. Oh, look! It did the 192.4. That's really weird. Maybe, are you guys doing it right? That's so weird.
That's my answer.
That was your answer, was the 192.4?
Yeah.
Okay, good. So,
Have you used Walmart was what I did?
I've used it once. Is it better than this?
It gives you options and it's just super like direct.
Okay, let me go ahead and write that. Or I'll remember, Kahoot.
Yeah.
I used it in this like professional developer workshop where we had to like share what strategies work best for students. And then when we used it, like all these things appeared on the screen. That's all I remember.
Oh.
It was like a long time ago. Anyway.
I might have worked out those bugs or something.
Yeah, maybe.
Yeah.
I know that whatever it did was not supposed to do that. This was 3 years ago, which is like a lot for you guys. For me, it's not a lot. You know how time. Anyway. Number 12, what's more affected by outliers? And I want an explanation for this one. So form your groups of 2 and 3. And I want to see some great answers. I'm actually going to come around and check whatever you wrote for number 12.
Sometimes like because it like divides by and uses all the values and goes to the middle ones. Outliers.
The number of because like the first time you have the you divided by 6 and then when you do an outlier you also include like an extra number that you divide by, so you divide by 5.
Yeah, like changes the whole.
Yeah, you're changing like the numerator and the denominator of your function.
Okay, so we know it's the mean. We know it's the mean, but why? How many values go into the mean calculation? That's immediate. All of them. So the reason is because all the values go into it. So as long as you referenced all, so mean because all values go into it. Okay, now things are going to start to pick up the pace here. This is the part of the lecture where things go from review to completely new. Okay, it turns out that you can use the mean. You can write the mean using these 4 symbols here. This is little n, this is big N, this is called sigma, and this is called x. Now, ignore this. I don't know what the hell that is. It's so weird. Okay, ignore that. Okay. And then draw whatever you think little n is. Capital N is sigma and x. This thing is kind of glitchy. Maybe I need to just do Kahoot. I don't know. It's like, it's really annoying. I can't get rid of it. It's still there. Okay, it just draw little arrows. Draw the arrow. Never mind. Just okay, do it. Okay, I want to see some arrows. It's not on your. It didn't print out on your paper. You know, I'm sending this to Microsoft. It's really annoying.
I have the text box. Wait, if you like, I saw the text box.
Yeah, you can press on.
Okay.
Maybe right click.
I'm trying to do that.
There we go. Okay. Thank you.
What are we supposed to do?
Directions. It's a matching game. In groups of 2, discuss where do you want to draw the line for the little n. Is little n each value, population, sample, or sum?
Okay. So I did one thing just on population band. Some is a student tree, and then X is each one.
Yeah, I really don't want to write. I don't know. So it's erasing.
Yeah, it's a good rule. I think that's X. I think X can be used to
No, I think you must
Sigma means the sum. Sigma means sum, so that's the first one. Okay. Population size and sample size, those are like almost the same thing. They both refer to the number of data that's in your data set. The only difference is that the population size means your data set is a population or really, really big. And sample size means your data set is a small sample. Okay, so because these are like almost the same thing, it's kind of like little n and big N, because those are pretty much almost the same thing. So here's a guess, is little n the small sample or the big population? Good. So sample size. Capital N is going to be, or the big N is going to be the big population. And that means X is each value in the data set. Now we don't have two different X's for some reason. I don't know why. It really should be little x if your data set is sample, and huge X if it's a population, but our mathematicians didn't decide to do that. They're just using a one-letter-fits-all approach. Okay, now that we've deciphered the symbols, we want to construct formulas for the sample mean and the population mean. So sample mean, the symbol is x bar, and population mean, the symbol is mu. So remember that the mean means to sum all the values and divide it by the total. So let's use these little symbols to say sum all the values and divide by the total. Okay, so let's try to do this. We can discuss this in groups. Sum all the values and divide by the total. What symbol is going to come first if we're summing all the values? Sigma.
But we don't say.
That's a red. And then will the other one be X over big N?
So what are you summing?
So, yeah, it's probably just the same thing over big N.
Okay, sample mean. Anytime you have a mean, you're summing all the values, so you need the sigma to indicate you're summing all the values. And what are we summing? All the values. What letter do we use for each of the values? X. So you need an X next to your sigma, because you're summing each value in the data set. So remember that. Sigma, sum, X, each value in the data set. And then you want to put, if you're dealing with a sample, little n or big N? Little n. Okay, population mean. Are you still summing? Yes. And what do I want to sum? Each value in the data set, and then I'm putting big N on the bottom because it's a population instead of a sample. Let's go ahead and find sigma x from the questions 10 and 11. So if we go back to 10 and 11, we see that here's the data. So this is the data that I'm referring, and that's not what this is the data that we're using for question 15. You want to use this stuff. So that's what we're using for 15. Find sigma x. You'll need a calculator.
The teacher suggested. Okay, I'm sorry.
Okay, I'm going to come around to check to see if we did this. Okay, it looks like we're pretty much done. Sigma means sum, x meaning each value, so we have sum each value. So we're summing each value. That means just to add all the values together. So we have 149 plus 906 plus 183 plus 107 plus 426 plus 97. And I actually didn't do that calculation. Let me see what it is. $18.68. Yeah. Any questions on number 15? Okay, things are going to change a little bit because now we're going to have a histogram here. And we already showed how to find the median in a histogram. Let's find the mean in the histogram too. But the problem with finding a mean in the histogram is that you know the number of people that had a GPA between 3.1 and 3.2? Well, it's 6, but you know if they got like a 3.11 or a 3.15, you know like the individual values? No. So, okay, so basically you want to summarize that. Okay, so what you're going to do is you're going to take two of these phrases from the boxes and you're going to put them together with a conjunction here. So an example is, let's say you pick the first two phrases, and you have, we do not know the number of students who earned a GPA between 3.1 and 3.2, and you chose and you do not know the number of students who earned a GPA of 3.1, 3.11, 3.101, 3.14, etc. So put two of those together and use an and, but, or in the middle. Okay, groups of two.
But you do not know the number of students who are
So I think one of these two first, and then, okay. We know the
Okay, so what do we know? Do we know, let's start with what we do know. Do we know the number of students who earned a 3.1, a 3.11, a 3. No, we do not know, or we do not know that. So cross this off. We do not know that information, so that's this one here. Do we know the number of students that earned a GPA between 3.1 and 3.2?
Yes.
Yes. How many were there? 6. So it's that one, statement 3. So, which one comes first? Good. So this one comes first, this one comes second, and put them together with a but. I want you guys to write it out. So correct answer is we know the number that were between 3.1 and 3.2, but we don't know the number that got a 3.1, a 3.11, a 3.101, 3.14, etc. Okay, so that gives us sort of a dilemma. So how do we find the mean? That's the problem, because we have to add all the values together. Well, any one of these situations could be possible for our 6 values that are between 3.1 and 3.2. In situation 1, are all these values between 3.1 and 3.2? Are they all between 3.1 and 3.2? Yes. What about situation 2? Yes. All 3 of these situations are possible. These for the 6 people that are between 3.1 and 3.2. So if we were going to find the mean, we'd have to add them all together. Let's go ahead and add them all together for each of the situations and see what numbers we get. So if you add the first situations together, you end up with 18.82. If you add situation 2 together, you get 18.96. And if you add situation 3 together, you get 18.9. Are these numbers that different? No. It turns out that if you make infinitely many situations, they're all actually going to be around 18.9 or around 18.9, maybe 18.8. Basically, no matter how many situations you make, you're roughly going to get the same. So, which one of these should we use? A, B, or C? This one's going to be a poll everywhere question. Which logically makes the most sense? You actually want the multiple choice one. Okay, A, B, or C? Oh, we're all done. Okay. Good. C was the correct answer. Do the easy one. Don't do the hard ones. So, C was the correct answer. Okay, so I'm actually going to start rewriting the histogram. So for the ones that are between 3.1 and 3.19, there were 6 of them. So to find the mean, I'm going to add 6 3.15s together. Another way to do this is to just multiply 3.15 by 6. Okay, now I want to finish these 2 columns here and then add my additional work, and then that'll help me find the mean. So let's go ahead and do that.
So pretty much,
I just,
we'll be able to find the middle value.
Yeah.
So
we have to know the data, we
Instead
know the data from
of those, at least the numbers. So I'm gonna keep it writing a lot.
Okay, so let's go ahead and start this one. So when we were looking between 3.1 and 3.2, who was our representative to add together? We took 3.15 because it was in the middle, and we saw from situation 3 that if you added all the 3.15s together, you basically got the same value that if you added any 6 values that were between 3.1 and 3.2 together. So just pick the value in the middle, which is the 3.15, and add 6 of them together, which is the same thing as multiplying 3.15 times 6. Okay, well, what about between, remember that this one's now going to be 3.30, so that makes this one 3.29. Who's going to be the representative between 3.2 and 3.3? 3.25, good. So to finish this up, we needed 3.25, and our frequency was 8. There were 8 values between 3.2 and 3.3. So how many 3.25s am I adding together? 8 of them, because there were 8 people between those two numbers. So I want to add 3.25 plus 3.25. One, two, three, 4, 5, 6, 7, 8. So that's the same thing as multiplying 3.25 by what value? 8. Okay, go ahead and finish this. Basically, how are the Yes. Okay, so I'm going to save some time here. And I'm just going to show everyone what the answer was. So if you fill this column in, it's 3.35. Then we have a 3.45, a 3.55, 3.65, 3.75, 3.85, and 3.95. And don't forget that you had, out of the 3.35s, you had 7, and then you had 6 of these, you had 5 of these, 4 of these, 3 of these, 2 of these, and 1 of these. And what are you going to do with all of these things? Add them all together, you get 144.3, and then is that the mean? What happens when you add them all together? You have to divide by the total. How many people were there? There were 42 people. It says 42 college students. Now you can find that by adding 6, 8, 7, 6, 5, 4, 3, 2, and 1 together will give you 42. So when you do that, your final answer for the mean is 3.43. It doesn't matter. You're right. I should round it to 3.44. You're right. Okay, so if we look at this graph at the top, which direction is it skewed? To the right. Skewed is the tail side. The tail's on the right, so we're skewed to the right. So you need to write that it's skewed to the right. And does anyone remember what the median was? The median was 3.4. Remember from number 4, we saw the median was 3.4. So here's our median. And our mean was 3.44. So how does the mean compare to the median? The median is blank the mean, smaller. So the last question asks us, why is the median greater than the mean if the data is skewed to the left? Well, then it's basically backwards. Everything's backwards, but there's another reason. So I'm going to assign that as homework. We want to fill in the last question. So just remember that when you're skewed to the right, the median's always going to be smaller than the mean, and when it's skewed to the left, the median's always going to be larger than the mean. Okay, don't forget to do the homework. See you next class. Also, make sure to subscribe. As long as you subscribe before I grade these quizzes, you'll get an additional point on the quiz.